Well, good morning, everyone, and welcome to another edition of Cosmic Coffee here at Lowell Observatory. I am Dr. Danielle Adams, standing in for Jeff Hall this morning, and I've got some wonderful guests with us. Kevin Schindler, who is the observatory's historian, as well as Lauren Amundson, who is the observatory's archivist and librarian. So welcome to both of you.
Great to be here.
Yes, we're glad to have you here, and we've got a really interesting topic. Today's Cosmic Coffee is going to be historically focused, and when you think about the history of Lowell Observatory, a lot of people go right to Pluto, right? That's probably what we're most famously known for, historically speaking, is the discovery of Pluto. But of course, there's a lot of other things that have happened in the last almost 127 years. And next month happens to be the 91st anniversary of the discovery of Pluto on February 18th. So that is coming up. And just to make you aware, we are having a virtual I Heart Pluto Festival this year. So you can go to iheartpluto.org and get all of the details and schedule for that. Hopefully next year we'll be back in person for that festival. But other than the discovery of Pluto, about 16 years before that, there was another really significant discovery that we're going to dig into today. So Kevin, why don't you tell us a little bit about that?
Sure, thanks, Danielle. And this is a really great opportunity to look at the heritage of Lowell. We think of Lowell Observatory, our kind of melded mission of research and sharing the results of that research with people. So really, science education is what we do. But we've been doing it so long, since 1894, that we've got really great stories to tell. And, stories from yesteryear, stories that are still happening with our Lowell Discovery Telescope that our scientists are using to make discoveries today. So when we look past that 125 plus years of history, like you mentioned, Pluto is certainly got to be at the top of the list of one of the most well-known things done here. And other well-known things like the reason Percival Lowell came here to study Mars and the supposed canals that he was seeing. And in later years, the rings of Uranus were co-discovered here. The atmosphere of Pluto discovered by scientists here. In more modern research, there's a lot of things through the years, but probably the most important, the one that changed astronomy in probably the largest way, was made by a name that outside of astronomy circles isn't very well known. And that fellow's name is V.M. Slifer. I wanted to show a couple slides here of V.M. V.M. Slifer, I think one of the reasons his name isn't as well known as others like Edwin Hubble, we're going to talk about, is because he was a very quiet person. He wasn't somebody who looked for attention. He was a farm boy from Indiana, who came from a large family, and he wasn't one to toot his own horn. And so, at Lowell Observatory, he was overshadowed by Percival Lowell, who was a larger-than-life character. And then, as we'll see later on, this correspondence with Edwin Hubble, who was a larger-than-life character. And so V.M. Slifer's name has never stood out as much as those others, but his contributions to astronomy are staggering. The first evidence of the expanding universe, the rotation of planets, the first evidence of cosmic dust, so many things that he contributed, which are remarkable. And I think to see just what his career was, it started off in an unassuming way. He had graduated from Indiana University, and his professor knew Percival Lowell here at the observatory. And Percival Lowell had an assistant, Andrew Douglas, that was summarily let go because of disagreements. And Percival Lowell wasn't really interested in bringing somebody else on right then, but he had promised this Wilbur Cogshall in Indiana that he would bring on one of his students to work at the observatory. And so Lowell wrote this letter back to Cogshall. I shall be happy to have him come when he is ready. I have decided, however, that I shall not want another permanent assistant and take him only because I promised to do so and for the terms suggested. What it was escapes my memory. If owing to this decision he prefers not to come, let him please himself. So that's the very uninspiring welcome to Lowell Observatory that V.M. Slifer got. He was the subject of this, just graduated. So he went to Lowell clearly initially just to be a temporary assistant. And 60-some years later, he retired from the observatory. And so, his career turned out to be a lot more than Percival Lowell or maybe anybody else thought it might be. One of the reasons Lowell agreed to bring him to the observatory was because Lowell had purchased this instrument called a spectrograph. And a spectrograph is an instrument you attach to a telescope, and the light comes through the telescope. And instead of an eyepiece, you have this spectrograph light comes through here and hits prisms. And these prisms break down light into their individual components. And so it allows astronomers to not only figure out what those objects are made of based on their light pattern, but if they're moving away from us or towards us, the Doppler shift, essentially. And this type of instrument is still used by astronomers today. This particular instrument is on display in our Putnam Collection Center. But this technique was something that had been around, but V.M. Slifer, who is shown here using it, he mastered it. Because what astronomers up to this point would do would point this at, say, a star and get the image and look at the pattern of lights and, like I said, figure out what that star is made of. Or they found if they did an exposure for more than a couple minutes, maybe 10 minutes or maybe an hour, they could see relative movement, like if the star moved moved toward us or away from us. And that's based on the Doppler shift. And I won't go into the technique of that, but that's what they were able to do with it. Well, V.M. Slifer was getting to know how to use this instrument, and Percival Lowell wanted him to look at Mars, to look at, see if there was any water vapor there. He also was looking at planets like Venus to see if he could determine the rotation period. And so V.M. Slifer got to know the spectrograph. It was painstaking. And so he got to know this instrument pretty well. And in around the early 1910s, V.M. Slifer followed Percival Lowell's direction to look at these faint, fuzzy blobs in space that at the time were called spiral nebulae. Today we know that those are galaxies, what we call today galaxies. But Percival Lowell was one of many scientists who thought these little blobs were protoplanetary systems, young planets being formed. And so he wanted Slifer to look at these objects with a spectrograph and look at their spectra and see if they matched those of planets like Jupiter and Saturn. And if they did, that would show a possible connection that these are, in fact, young planet systems. Well,
Kevin,
what I found was that...
Sorry, Kevin, do you know, is there any indication that V.M. Slifer himself was also interested in this particular course of study, or did he embark on it just because Percival had that interest?
This particular part of it was because Percival wanted to know this, because Percival, in studying Mars, he also studied other planets, and he developed this idea about how planets evolve over time. He called it planetology. And essentially, he saw planets as starting out as young, they're gaseous, as they go through life, the gas dissipates, they're solid, and so like Earth and Mars are in that middle stage, but eventually they dry out and become dead like Mercury. And so Lowell thought that Mars, it was in the same stage of evolution as Earth. It has clouds that we could tell. And so he wanted to show, in understanding these planets, he wanted to look at these spiral nebulae and see if they were in fact young planetary systems. That then he could learn more about and explain more about this idea of planetology. So this was more of a Lowell idea. Slifer did have his own research for the spectrograph, looking at stars and other things, but this particular thing was personal Lowell. And so Slifer, in doing these spectra of the spiral nebulae, realized that the signature, the composition of these nebulae didn't match the planets. So that was kind of a downer. It didn't make that connection Lowell thought it would. But what Slifer found was something incredible, that these objects were moving at speeds in excess of 900 times or several hundred times the speed of sound. That was unheard of. And the reason it was unheard of, because nobody had made these observations. Previously, people using spectrographs would maybe do an observation for an hour or two. He did them for tens of hours. Looking at the same object, he would set the telescope and spectrograph up, and essentially you're taking a picture with this thing. And so he'd have the shutter open, and the telescope is slowly following that object across the sky throughout the night. Once it set, he would close the shutter, wait till the next night, reposition the telescope where that object was coming in, open the shutter, and continue that exposure. It's incredibly detailed and tedious. Nobody had done this. But by doing this, he was able to see pick up really faint detail of the at incredible speeds. So a couple of years later, he reported this at one of the major astronomy meetings, the American Astronomical Society, and he got a standing ovation, because what this showed was that the universe must be much larger and vaster than anybody had realized. And the picture of me, you can see the red arrow, that's pointing at V.M. Slifer. So he's at this meeting, he's really made a name for himself. There's somebody else at the meeting, and if we look to the lower right in the picture, the blue arrow, his name is Edwin Hubble. Edwin Hubble is and Edwin Hubble listened to these results, and this partly inspired his future career to look at these faint fuzzy nebulae. There's a close-up of Hubble. To look at these faint fuzzy nebulae, and using some of the results of that V.M. Slayfor found, plus his own results, he, in the 1920s, came up with a theory of the expanding universe, which then out of that grew the Big Bang Theory. And so our idea of how the universe formed and evolved through time has its basis in people like V.M. Slifer, who first detected that expanding nature of the universe. He didn't know what to make of it, just that the universe was much larger and vaster. So
we've got a question connected to this from Peak Art, who asks, so was he, V.M. Slifer, technically the one to discover other galaxies?
Not really, because the Andromeda Galaxy, we didn't call it a galaxy at the time, but it was known before then. And other people had seen these faint fuzzies, and Slifer didn't identify them as a galaxy as we know today. He just saw these faint fuzzies, and they were still called spiral nebulae. It wasn't until the 1920s that astronomers realized these island universes are systems among themselves, and all these little faint fuzzies are systems that have, several 100 million stars in them, and all of them make up our galaxy. But Slifer's work was critical because it showed the expanding nature of these things, and that helped realize that they were independent things, all part of our universe, but independent star systems. So with this discovery of Slifer, then Hubble coming on the scene, starting in 1922, they began this correspondence back and forth, because while V.M. Slifer mostly reported his findings, Edwin Hubble was a theorist. He used his own findings as well as those of Slifer and others to formulate these theories. So through the years, they would go back and forth with this correspondence, sharing data and information. And from 1922 until right before Hubble's death in 1953, they wrote about 50 letters back and forth to each other that we have in the archives. And thanks to Lauren and her crew in the archives, these are preserved and now usable by researchers around the world.
That's awesome. And, this, of course, is now why we have Lauren here to give us a peek into those letters and how they were preserved. But before we go there, what is your sense, Kevin or Lauren, on, we have, of course, the Hubble constant, we have the, which is now the Hubble-Lemaitre law. Is there any sense that V.M. Slifer will get his recognition as part of this whole complex?
Well, there's certainly, especially in recent years, there's been a push among some scientists and science historians to do that very thing, to maybe rename that Hubble-Lemaitre law the Hubble-Lemaitre-Slifer law, just to make it as big of a mouthful as possible. But there is a growing push to bring that recognition to V.M. Slifer for that work. And the work he did was groundbreaking. And when you think, it's like Clyde Tombaugh's discovery of Pluto. The discovery itself is made more remarkable by the tediousness and the dedication it took to make it happen. And I think, to me, that alone, and then what we learned from that is, it's a story that more people should know. So bringing more attention to V.M. Slifer, I think, is a really important thing.
Indeed. Okay, so Lauren, how do we go about this process of preserving the letters and really digesting the contents and making sure others have access?
So that, the purpose of our collections here, of our archives, is to collect, to preserve, and to provide access. And so we want to make sure that we can do everything we can to not only ensure the preservation of the collections long-term for future generations, but also to make those materials accessible in any way that we can, while also ensuring their safety. And so I'm going to talk a little bit today about the preservation process, and then also how we decide to digitize materials for access purposes. So right now I'm sitting in the Putnam Collection Center. I'm in the repository where it's a balmy 63 degrees right now. And I'm going to turn my camera around and give you guys a little tour, show you some of the original letters, and then kind of where we keep things and how, like, our process for housing collections here. And then I will turn it back over to Kevin, and with his screen share, he'll be able to bring up the digitized collection of letters between Slifer and Hubble on our website and give you guys a peek of how those look online and how to navigate it freely accessible to everybody, which is our goal. So let me go ahead here and turn my camera around. Okay, so just to kind of give an overview of this room, this is the repository. We've got our mobile shelving units, which I'll get into a little bit more detail here in a second. But we've got a really good collection of various artifacts, some hand-drawn Mars globes from Percival Lowell, various pieces of equipment. And then on this side over here, we've got our paper collections. And so generally, when we receive a collection, it can be a complete disaster, or it can be very nice and orderly. And so our job is to bring it in, appraise it, figure out what do we have here, what are we looking at, do a pass through the collection, weed out any materials that, you know, may be duplicates or are unnecessary, you know, things like reprints, because we really try to focus on primary sources that can't be found anywhere else. That's the purpose of the archives, is to have primary sources. So things like, you know, original letters from Percival Lowell, V.M. Slifer, C.O. Lampland, who was another astronomer here, you know, letters that you're not going to find anywhere else, versus a library, which we also have, which is books, secondary sources that you can find in other places. So that's our goal, is to collect those materials that are unique to Lowell Observatory. And those go back to our founding in 1894. So just to kind of give you an idea, this is what a processed collection looks like. We call it processed when it's been inventoried, rehoused in new archival boxes, labeled, cataloged, and is available online for discovery, whether through just what we call a finding guide, which is a text-based guide that will give a box and folder list, or through digitized materials where the actual document itself has been scanned and is available. And so a lot of people ask, you know, well, are you going to digitize everything? There's just no way. It's too much. You know, the time that it takes, the staff, the money, it would really be impossible to digitize everything. So what we do is we kind of do it on demand. So if we have collections that are, you know, really popular, for instance, Percival Lowell hand drew some Mars maps, we've digitized those. If we have items that are frequently asked for example, the telegram from Venetia Burney when she was suggesting the name Pluto back in 1930, we've digitized that. So it's kind of a combination of what's cool, what gets a lot of use, and just things that we want to get out there.
Lauren, we've got a question that's come in from Chris Georgie, who asks, do you seek out individual pieces of ephemera or just accession collections?
Oh, good question. We don't really seek out a whole lot. Generally, it's just accessioning collections. So if somebody retires or, you know, passes away and has willed their collection to us, I haven't really ever gone looking for items. I know that there's a lot of stuff out there. I've seen, you know, like signed Percival Lowell letters and books, occasionally on eBay or on auction sites and things like that. Sometimes if the price is reasonable, I've pursued that, but a lot of times we're talking thousands of dollars for like one letter, and that's just something we can't justify here. So that's a great question. Okay, so back to we'll talk about V.M. Slifer collection. So you can see here's his correspondence, and we were actually, you wouldn't normally have sticky notes on this, but this was a project that was in process when the pandemic hit and we shut down for COVID. So I had volunteers working on this project, and that was almost a year ago. And unfortunately, you know, they haven't been able to come back, but we're in the process of kind of reorganizing this. When we bring a collection in now, we have an industrial freezer that we put the collection in for 2 weeks at minus 25 degrees Fahrenheit. And the purpose of that is to kill any bugs that may have gotten into the collection. So if you have, you know, some sort of insect infestation that's gotten in there, we want to make sure that we don't migrate that into the larger collections. And so we did that retroactively with a lot of these older collections that had already been processed when we moved over to this building in 2014. And then any collections that we get now, we make sure that we run through the freezer as well. So just to kind of give you guys a look of what that looks like. Again, the mobile shelving is really nice. It's on these rails in the floor. And so these just slide really nicely, and can kind of see more of our collections down these units here. And so do we have any questions?
We do. We have another one from Chris. Do you put them under inert atmosphere in the deep freeze?
No. Simple answer. No, it's just the freeze. And then, we take everything out and check it and make sure that there's no signs of an infestation. And if we're good to go, we bring it into the repository. If we see any issues, we put it in quarantine and check on it later until there aren't any problems. So, which so far we've been lucky not to have too many. All right, let me head back here to the Slifer Hubble correspondence. So as Kevin said, there are 50 letters starting in 1922 and going, I think we said till 53, which was when Hubble passed away. But they are preserved here in our archives. The process for that is, like I said, we get a collection, we organize it with correspondence, we organize it by obviously the two people corresponding, and then also chronologically, so that if a researcher is looking through a folder, they can start at the beginning and follow the whole conversation. Some folders, have one letter between two people. Some folders have hundreds of letters, and you actually end up needing multiple folders because, people were corresponding back and forth so much. So this collection of 50 letters is a good modest size. So like I said, we keep everything in these archival boxes, archival folders. You don't want the acid migrating. You've got this old paper and everything, and things like ink and typing and all that. So, and then the repository itself, the storage conditions, we keep it dark, cool, relative humidity at about 45 degrees. We try to, limit handling as much as we can. Obviously, we don't want to be, touching stuff more than we have to, which is another good thing about digitization. So just to give you guys kind of a quick view, here's Hubble had beautiful handwriting. As an archivist, I've seen beautiful handwriting. I've seen complete chicken scratch that you just can't even, tell what they're writing. So this is nice. Some typed letters. And then I like this one. So they were talking about forming a committee on nebulae, which of course we know now to be galaxies. And so Hubble wrote this 5-page letter to Slifer, and he's got, annotations in the margins. And he's basically talking about all the different classifications and things that he wants to do. He wants to do a general survey. He's talking about photometry and just all these various things. And then you just see all of his notes. And so this is just really cool because this is a great example of a primary source. This letter is from 1922. So the two of them just kind of starting their correspondence and talking about, hey, we've got some cool stuff going on here, trying to figure out what it is. And that goes back and forth between the two of them for about 30 years, which is really cool.
That really is marvelous to see. I'm sure none of them at that time imagined that these letters would be preserved for posterity. So it's quite something to be able to look into those thoughts and even the notes on the margins. Are they, it's his notes on his own letter, correct? So
yes, yeah. So it looks like let's see if I can kind of focus in. Again, Hubble's nice writing. This almost looks to me like Slifer's writing, which I've seen a lot. And so it looks like maybe the two of them were making these notes. And, you know, Danielle makes a really good point. At the time, of course, they're not thinking about this for posterity. This is their work that they're doing. You know, and that's one of the things that I try to encourage our current faculty, our current astronomers to think about is, you know, the work that you're doing now, obviously, in 50 years from now, 100 years from now, you know, historians are going to want to look at that. And so I really try to encourage them to think about, you know, when you retire, you know, think about leaving your papers to Lowell or, you know, really to wherever archive is appropriate, because, you know, we're really trying to build that collection and make sure that we don't just have our history look like it ended in, you know, 1950. We want to make sure, hey, it's 2021, you know, we're getting collections in now that are going to be, you know, important to show what we're doing in the present day.
And, you know, Lauren, that's a really important point related to that is, you know, we think about looking back at a previous time when people wrote letters and telegrams. And today in the digital world, we talk about emails in which, you know, the majority of people don't preserve those. And we go down 50 years in the future. What are we going to know? You know, the personal parts of letters, you know, things like seeing handwriting, like you said, you can identify V.M. Slifer's versus Edwin Hubble's. We lose some level of that by gaining the technology. And that's a tough question to answer, the best way of handling that.
Right, and that's a very big challenge for archivists today is, you know, preserving emails and how do you make sure that data is available, and we're losing thousands of records every day. So yeah, definitely a challenge, but one of the reasons that we digitized is that we want to, you know, save those records, but the primary reason is to provide access. So obviously, you know, not everybody can come visit the Lowell archives in person and look at these letters, especially in a pandemic. A lot of archives have really had to up their digital game and start digitizing a lot of materials to make them available online. And so even before that, so in the fall of 2019, I had an intern. He was a student from the University of Arizona in the library science program. His name was Zachary Peach. And one of the projects that I had Zach work on was to digitize the Cipher Hubble letters, because this was something I'd been thinking about for a long time. Obviously, it's a very historically significant collection. And so, you know, Zach was there for the semester. And so we sat down and I, you know, showed him how to properly scan everything, you know, save our various file types, the large master TIFF files, and then the smaller JPEG access files, you know, following best practices for archives. And so once he did that, we decided to upload everything to Omeka, which is our digital publishing platform. And that was a really fun project because, you know, Zach got to go through, he got to read every letter, scan it, you know, combine them into PDFs, and then go through and do what we call the descriptive metadata, which is jargon, but it's basically just, you know, title, date, creator, description, those basic things, so that anybody who's searching subjects, you know, anyone who's searching our database can go and find what they're looking for. And so that was really exciting for us to finally get this collection online and available to everybody in the world, essentially, which is something that you can't do, you know, without the digitization.
And I know we're going to take a look at Omeka, but before we do, we've had some more questions come in. Some of these are process related. So Chris asks, how do you deal with mildew or fungal issues in the archives?
That's a good question. So luckily, because we're in such a dry climate here in Flagstaff, we haven't really encountered a whole lot of mold or mildew. When we have, we make sure that we can use a UV light to test whether the mold is active or inactive. If it's inactive, we can actually safely store it in our collections area, just as long as we make sure that we monitor it, don't have it mixed in with other materials. And if you keep your conditions right, for example, low humidity, cool, dark, the mold, should stay inactive. If we have a case of active mold, then we do not mingle that material in with the other collections. We keep it separate and isolated from everything, and just kind of continue to monitor it. But again, I haven't seen a whole lot of that, and I attribute that to the climate here in Flagstaff, which is great.
Lauren, if it is active, what do we do to make it inactive?
I think it's more of like would probably want to call a professional conservator and have them come in and deal with it, because they could do like a chemical treatment or something like that. I'm not qualified for that. So if, let's say we had a really bad case where we had a collection or, some rare books that came in that had an active mold problem, that's where I would call a conservator to come in and deal with that.
I think back of my old days working at a natural history museum in Florida, where humidity is a big problem, and we were getting collections of fossils, and back then they would just fumigate. Freezing is a much environmentally better way of doing it, but that's how it was done back then. But then also, once you have the collections, you have the humidity and things like mold and stuff like that is a much bigger problem to deal with. The climate of Arizona, it's great for telescope viewing. It's also great for preserving stuff, paper stuff.
Mm-hmm. Yeah, absolutely. I'm very, very grateful for that. Makes my job a lot easier, for sure.
Indeed. Okay, we have, let me see, DP asks, do most scientists save their correspondence, or was that pretty common at the time? Letters, sort of like a very full inbox and email.
Yeah, I mean, very common at the time to save their correspondence. We have hundreds of linear feet of correspondence. I know that other archival institutions that collect, that focus on science have large correspondence collections as well, which again is fantastic, because you see the progression of the research and the ideas and the conversations that were going back and forth as people figured this stuff out and worked on the projects. So very common to see that in the era of letter writing, and then with the advent of email, we got a collection in from our retired director Bob Millis, and he, or I think it was his assistant, had actually printed out all of his emails before he retired. Who does that? That's just not a thing anymore. But it's great that we have all that, but it's worrisome too going forward. What are you going to lose because you don't have those printed letters or emails?
And Lauren, something else about the old time way of keeping the records is they also had, like you have in the collections, when you wrote a letter, you made a copy of it. I don't know what those books were called, but so we have these copy books. And some of them are really hard to read on onion skin paper, but we not only have letters that were received, but we can see the original content of what was sent out. And it really puts it in context, because it's great to have letters, but sometimes they're an answer to questions that aren't fully explained. Well, we can go back and see that, and it really helps fill in the story a lot more.
Mm-hmm. Another question from Grimbeard. Are letters like this used as reference materials by people making documentaries or docudramas to help with scripting?
Oh, I would say that I've probably gotten a couple requests like that over the years. Not very often, but people do like to use sort of the kind of the human element of the letters to do that. I can't off the top of my head remember specifics, but there's been a couple. It's not as common as other requests, but
and there have been a couple, like maybe even before you were around, Lauren. I can't remember the timing, but especially related to Pluto and kind of recreating the discovery, where they looked at the letters and used some of the same, speaking styles and verbiage and exactly what they said to make it sound authentic. So yeah, it has been done, some that I know of. And besides that, on a different scale, name a television program or documentary source like History Channel or Discovery Channel or National Geographic, and pretty much all of them at some time or another, or many times, have been here and used stuff in the archives and artifacts in the programming. And so not necessarily just looking at that to getting dialogue, but you just focusing on that and highlighting it. The fact that we have this collection is really important because it helps document it, and these places that make the documentaries then help us share it that way. And sharing it other way, I saw a question, are these letters available for the public to see? And it's difficult. I mean, you can talk about that a little bit, but it's letters, for instance, you don't want to be handled by a lot of people, but making them digitized allows anybody to see them from the comfort of your living room if you want.
Right. Yeah. Obviously we want accessibility to be a big part of what we do. We don't want to just hide all these collections away and not let anyone ever see them, because then what's the point of collecting? So, to digitize these collections obviously makes them much more accessible. Here at Lowell, if somebody wanted to come in person and look at the collections, they would have to make a research request appointment ahead of time, send me, a project proposal and a resume and that type of thing. And, we also try to put artifacts out on display in our exhibit area that's open to the public. A lot of times we'll make facsimiles of things just for the safety of the items. But there's various ways that we can allow the public to see these materials and also ensure the safety of the materials themselves.
And Lauren, you said something there that I think is golden because it goes back to our director. You said essentially, if we're not sharing these with the public, what's the point of preserving them? And that goes back to, the mentality of our founder, Percival Lowell, in doing the basic science. He said, what's the point of doing science unless we make it available to everybody and share it with them and make them co-discoverers, and so that humankind can all share in it. And I think that's an approach that the observatory still uses, both in doing science and sharing the results and in preserving our important heritage.
We've got a few minutes left here. Let's go ahead and take a look at Omeka as we're talking about public access.
Sure, let me bring that up here. So it should be showing right now. And our most important behind the scenes person, Heather, is going to share the website address. So anybody with a computer, they have internet access, you can click on that and look at all these on your own. But this is how this is arranged. And there's, for each letter, there's a little bit of a highlight so you can kind of see what the topic is. And if you want to read it, all you do is click on this, and there's the beginning of a letter, and this one has, I think, several pages. This is the first letter we have in our archives between them. This is February 15th, 1922. If I scroll down, you'll see there are several pages, and then from here I can scroll also. And when you're in here, there's a lot of things you can do. You can enlarge it, make it easier to read and change the screen and such. You can print this out. So it's a very, again, like Laura said, we want to make this accessible for everybody because this is just really important stuff, important to the history of astronomy and science in general. I'm going to go to the last page here. So there's a certain number of letters on each page. And then if I go to the last one, it's actually not with Edwin Hubble, but it's a letter from V.M. Slifer and his wife to Grace because Edwin had died. And so let me just enlarge this a little bit. And it just says my heartfelt sympathy is extended in your great. I'm not quite sure what that says, but it's just expressing this difficult time and how V.M. Slifer was a very understated person, and for him to underline his cherished friend, I think is really meaningful. When you look at this correspondence, it's really fascinating because you can see how they became more friendly over time, but also how much they respected each other. They were from different backgrounds, different personalities, and yet they really, based on this correspondence, really respected each other.
Kevin, we're up at time here, but one last question that's related to this is from Peter Rosenthal, who asks, on a personal note, did VM ever feel slighted as someone else ran with his discoveries?
Well, first, hi, Peter. It's great to hear from you. Peter Rosenthal is a valued member of the Lowell family, retired now, but he was instrumental in refurbishing the 24-inch Clark telescope and the Pluto Discovery telescope, among other things here. So it's great to have Peter on the line here. V.M. Slifer publicly, he was a quiet, understated person. So publicly, he never said much about if he thought he should be getting more attention or not. And even privately, if you look at letters and telegrams, he just doesn't say much about it. My sense is he might have had a little bit of angst about it based on conversations with Henry Gickless, who I worked with in the later stages of his career. Henry had overlapped with VM, but he just never talked about it much.
All right. Well, thank you so much, Kevin and Lauren, for spending time with us this morning here at Cosmic Coffee. It's fascinating. There's so much research that Lowell Observatory is doing now. And, then when you go back almost 127 years to imagine all the research that's been done over that time, it's fantastic that some of this is actually available for the public to digest.
And Danielle, what else I think is important about that is, it's easy to find the results of science or the big discoveries, and you can look up on the internet and find that, but the stories behind them and the people who made these discoveries and spent their careers painstakingly doing this work, a lot of that is revealed in correspondence like this. So to be able to have that correspondence really tells the human story of doing science and of doing what you love and of the sacrifices you make. So I think that's another aspect of this that makes it really valuable.
Indeed. Science is a process that happens before that famous discovery. It's really kind of the end point of a lot of work that's gone on before it. Okay, great. Well, thank you all for joining us for Cosmic Coffee. A reminder that next week we'll be back again at 9 a.m. for another cup of Cosmic Coffee. Also, we have on Tuesday night our interactive stargazing episodes where you can request objects for us to take a look at on these cold winter nights where we have beautiful scene up here on Mars Hill. So that is at 8 p.m. Mountain Standard Time here in Arizona on Tuesday nights. And until then, have a wonderful week, and we'll see you next week. Thanks so much.